All right, so we're on 3.5b, reciprocal function, okay? The reciprocal function in general form is y equals a divided by x minus h plus k. That's the general form of it, okay? Where a cannot equal 0, so a cannot be 0, and x and h cannot equal each other. Okay, the graph of this equation has what's called a horizontal asymptote at y equals k and a vertical asymptote at x equals h. Okay, asymptotes. Does anyone remember what an asymptote is?
It's like the border line that stops it from crossing.
Exactly. Well, it could be x-axis or any axis, right? It's your imaginary boundary line. Boundary line. So that's your asymptote. And this function has not only a vertical, but also a horizontal one. Okay. How many of you remember from Algebra 1 the term hoi vux? Does that ring any bells? Yeah. Hoi vux? It was written up there. Okay. Hoi vux. So hoi vux is a way to remember what a horizontal function, the attributes of a horizontal line, the attributes of a vertical line. So if I have a horizontal line, it has 0, a slope, and it's written as y equals something. So y equal a number is a horizontal line. Y equals 0, y equals 2, y equals 3, y equals 4. Those are all going to just be horizontal lines, right? Vux, that's a vertical line. Okay, its slope is undefined. So the slope of a vertical line is undefined, and the equation is always going to be x equals a number. So I remember learning this in 8th grade, and being the typical obnoxious middle schooler. I decided that this is going to be my math cuss word. So anytime like something made me mad in class or it wasn't working for me, I'll be like, oh, hoi vux. And it used to make my teacher mad, but I didn't. I said hoi vux. So the times, okay. Yeah, where we still respected our teachers and didn't curse in front of them. You're right. Those were the good times. So here we go. But that's how you remember. So when you're trying to figure out if it's a horizontal asymptote, just remember hoi vux. It's horizontal because it's y equals something. Okay. The two members of the reciprocal function family. The first one we talked about yesterday was our inverse variation function. Do y'all remember talking about that yesterday? Yes, inverse variation. The only difference between today and yesterday, we started off by defining it as k equals x times y. And we said that that is our y equals k over x, right? That's the only difference is the letter k. Everything else is the same, okay? When a equals 1 and h equals 0 and k equals 0, that's where our parent function comes from. The parent reciprocal function is called y equals 1 over x, okay? So what we have graphed here is our parent reciprocal function. So you either can use a dashed line or a highlighter, whichever one you want, or half. But we're going to highlight our asymptotes. So our vertical asymptote, a lot of people get confused and they want to say it's at y equals. But vertical means that it's going to be in x. So this is at x equals 0. That's our vertical asymptote. Notice how as our function gets close to it, does it ever cross it? No. Our horizontal asymptote, which is right here, is at y equals 0. So even though it's on the x-axis, it's horizontal, and the equation for a horizontal asymptote is y equals, or y equals a number. Okay? These asymptotes cause restrictions in our domain. Okay? So when we look here, our domain, x cannot equal 0, right? We'll never have x equal to 0. So our domain is x cannot equal 0. It can be anything else, but not 0. Does that make sense? Okay. When we write this in interval notation, we're going to use parentheses only. And we're going to use a new symbol, which is our union symbol or our or symbol, okay? When you're describing the domain, you start all the way from negative infinity, correct? Because the graph goes on forever. So my domain would be from negative infinity. However, I'm traveling along and like, oh no, I can't get to 0. So I have to stop at 0, then start over. This is your union or your or. And then we continue from 0, and now we can continue to infinity. The same thing happens with our y's, right? Our y's can go as low as negative infinity. And then as they try to travel to positive infinity, oh no, they can't do what? They can't touch 0, right? So y cannot equal 0, which means that it goes from negative infinity to 0, stops it, and then it can continue from 0 to infinity. No, there's no value. Notice that it's parentheses, not a bracket. A bracket means that it's defined, and I'm not defined at 0. Okay, and because I do not touch the x or y axis, do I have any intercepts? I do not. There are none.
No intercept.
There are no intercepts. Okay. And these restrictions are caused by asymptotes. And I have a vertical. And where's my vertical at? At x equals 0. And I have a horizontal at
Y.
perfect. At y equals 0. Okay. The last thing I want to note about this function is that it is an odd function. So it's called, the parent function is an odd function. The reason why it's odd is even though I technically don't go through the origin, I do have my restriction goes through the origin. And then the other thing is, if you were to turn your paper 180 degrees, does the shape of your function change? No, it's exactly the same. So this is an odd function. All right. So every parent, for the most part, in terms of functions, not people, because not every adult is a parent, right? But in terms of functions, they have transformations. They have children, right? So we're going to talk about how to graph and analyze the children. Okay. So the first thing you want to do is rewrite in general form of the identity and identify AH and K. So by general form, you want it to be written as y equals A over X minus H plus K. Okay. So you want to make sure before you start that y is by itself. Okay. Next, you're going to identify and graph your horizontal and vertical asymptotes. Remember that your horizontal asymptote is your y equals your K. So whatever K is, that's what your horizontal asymptote is. Okay. Your vertical asymptote is going to be X equals H. So whatever H is, that is what your vertical asymptote is. Remember about our X's in transformation. X's are what? Liars. Okay. Then we're going to make a table of values for the function and plot the points and then connect them, and we're done.
Oh, wait, so what comes X and the H?
X is your independent variable, so it's not going to change. X is just there. H actually can be something. H is, yeah. And then we're going to state our domain and range. Okay. All right. Are you ready?
Yeah.
We're going to start off simple, and then we'll throw in some H and K's. Right now, we're going to start off with H and K being 0, just to get used to the graphing. Is that cool?
Yeah.
Okay. So step 1 says to make sure you're written in standard form. Am I in that form? Yes. If you want to see it in a full-on situation, it's just basically saying this, right? Is it necessary to add and subtract zeros? No, it doesn't change the function. Okay. Because there's no H and K present, we know that our vertical asymptote is at 0 at what? X equals 0. And we know that our horizontal asymptote is at Y equals 0. So I'm going to go ahead and draw my asymptotes. So
Oh,
okay. After that, step 3 is to create your table. When you're making your table of values, you want to think about what is going to be easy to graph and or divide by what's in the numerator. So I have -5 in the numerator. Well, starting from left to right, -5 is pretty easy to divide by itself, right? I can't use 0. It's an asymptote. I can use -2 and -1. But I don't want to choose anything that's going to be harder for me to divide and actually kind of graph as accurate as possible. Does that make sense? So -5 divided by -5 is 1. -5 divided by -2, 2.5. -5 divided by -1 is 5. Because this is an odd function, for the x values in their opposites, these are going to be also opposites. Does that make sense? And if not, just do the math. What's -5 divided by 1? -5. What's -5 divided by 2? -2.5. What's -5 divided by 5? -1. Okay. And these are the points you're going to plot. So I'm going to go to -5, 1, 2, 3, 4, 5. Hopefully you don't need me to plot points. So we should all be done at the same time. And then you're just going to connect the dots and follow your asymptote. But do you cross it? No. You do your best not to touch it, but. So I'm at 1, -5. And then I'm at 2, 3, 4, 5. And we're gonna. Okay. Bam. Last part is to state our domain and range. Because it's just like its parent function in that sense, the domain and the range are still just going to be from -infinity to 0, union 0 to infinity. Okay, questions, comments? Okay, I'm going to give you at your table 5 minutes to do practice 1 and 2. So at your table, you're going to do practice 1 and because we don't have it. Yeah, right now we are. It's not going to always be. We just get where. All right. Here we go. So really quick. We already know that the asymptotes are where? At 0, at x equals 0 and y equals 0, because there's nothing being added or subtracted. So these are our boundary lines. Okay, the tricky part is your table, coming up with your values to graph. So what values did y'all choose to graph? What x's did y'all choose?
9, 6, 3.
Okay, I would have just chose 9, 3, and 1.
Well, I mean, yeah, but.
And so when I plug these in, I should end up with -1, -3, and -9. So I would have +9, +3, and +1. Okay, so when we say friendly numbers, you see these are easy numbers to manipulate, right? So I'm going to go graph them. So I went to -9, go down to 1, done. Go to -3, 1, 2, 3, go down 3. Go to -1 and go all the way down 9. And my graph on this side is boom, boom, boom. Then I'm going to do it here. go to 1, go all the way up to 9. Go to 3, go up to 3. And then go to 9, 3, 4, 5, 6, 7, 8, 9, and go to 1. Follow the curves. Okay. All right, so the domain here is still what? The domain and the range are still going to be
2 and 0, 0. I mean, yeah, negative, positive.
all that jam, right? Okay, this one, was it in the correct form?
No,
No, so what did you have to do?
I made many quadrats, you know?
You just had to divide your x. You get 2 over x.
Yeah.
Yeah. I don't know how you got many quadratics, but let's. So again, because of this, our asymptotes are going to be at x equals 0 and y equals 0, because nothing's being added or subtracted. Shh. I know, you're just talking loud. It's just you two talking to each other. You don't have to yell at everybody else. Okay, so I'm looking at that line did not go straight at all. I don't know what happened there. It's tired. All right, so thinking of numbers that are easy with 2, I would probably just use -4, -2, and -1. 1, 2, and 4.
Yeah.
So I got -0.5. I got -1. I got -2. And then I got +2, +1, and +0.5. 2 divided by 4 is a half. Right? Okay, 1, 2, 3, 4. And then at -2, I'm at -1, and at 1, I'm at -2. So notice it's getting a little closer and closer, but is it going to ever touch it? No. You're stuck in it's stuck in the friend zone. Some people need to be in the friend zone. Okay. And again, the domain and range is still going to be the same. All right.
Are we done?
We're done with that.
A bit more.
Don't you have the paper? It's like you have the paper. All right, so here we go. Part dose. Okay. So part 2 is when your H and K are no longer just 0. Okay, that's it. When your H and K are no longer 0, what's happening? Well, those are going to be our horizontal and vertical transformation. So H is our horizontal, telling us whether we're going left or right. And our K is going to be our vertical, telling us whether we're going up or down. Yes. Okay, when you have a negative, it actually belongs in the numerator. So it's -6 over x plus 3 plus 2. Okay, from here, I'm going to identify my H and my K. So H equals, X is a liar, so H equals what? -3. And K equals what? 2, +2, right? Why lie? All right, so because H is -3, that means I'm actually going to the left, right? K is +2, so that means it's going to go up, right? Same transformation rules as quadratics. Nothing different. All right, but this also tells me that my H is still going to be my what asymptote? It's still going to be my horizontal asymptote, right? So, not my horizontal, my vertical asymptote. You made me say it right. So I still know that it's going to be at x equals -3. Okay. Whatever. What did I do wrong? Oh, I did.
Come on now, you can't be doing this.
My bad. Y is K, X is H. What did I do wrong? I didn't do anything wrong. Why y'all make me think I'm crazy? I didn't. I said my x is -3. And I wrote y is 2. All right. So therefore, putting it all in, go into your asymptote. So at -3, I'm drawing my vertical. I think y'all just thought H meant horizontal, and that's why y'all told me I was wrong. Okay, so that's done. I described the transformation. I described what's happening. Now, the third part is still thinking about it in terms of -6 over x, like making your table based off of that. So when you're making your table, your x, you're still going to think about it in terms of if I have -6, y equals -6 over x. What are friendly numbers I can use here? I can use -3, -2, -1, 1, 2, and 3. Agreed? -6 divided by -3 is? -6 divided by -2 is? 3. -6 divided by -1 is? 6. And it's going to be their opposites, right? -6, -3. I lost brain track right there. And then -2. Okay. The difference now is that, hey, my line disappeared. Did y'all see that? When did it go away? Huh. Okay. Oh. Anyways, so the difference here, guys. So this is your table, but no, remember our origin is no longer here. Where's our origin at? It's over here. So I'm not counting just 3 from here. I'm counting it from here. So I'm going to go -3. So I'm going 1, 2, 3. Then I'm going to go up 2, 1, 2. That one's done. I'm at -2, 3. So I'm going to go 1, 2. Then go up 1, 2, 3. Then I'm at -1, 6. So I went to the left 1 and up 1, 2, 3, 4, 5, 6. And then I'm going to just boom, 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 boom. Okay, I'm gonna do the same thing with the other values. So I'm gonna go right 1 and down 6. 1, 2, 3, 4, 5, 6. I'm gonna go right 2 and down 3. 1, 2, 3. I'm gonna go right 3 and down 2. And then do my best to not touch that. Good, don't touch. Boom. Okay. There's my graph. There's my situation. So this is just used to help get to these points. But are those the actual values of this table, of this graph? No. Okay. Your domain. So now your domain, it now goes to -infinity. But what stops? Where do I stop at now? I stop at -3, right? So I stop at -3 and then I continue from -3. Okay, your range, where does your range start and stop? It starts at negative, but it's gonna stop at 2.
Oh, yeah.
Yeah. Okay, so the takeaway here should be that your H and your K tell you a lot. It tells you how your graph is moving, and then it also affects your domain and your range. Yeah? Okay, you're not gonna do your exit ticket, you'll do it on Monday as your do now. It's in a little bin next to the thing. I will change the date. All right, so continuing with 3.5b reciprocal functions. This would be the hardest that it would get. And what typically makes you guys freak out is that it's fractions, right? And you're like, this is nothing like we've ever done. Oh no, fraction. Okay. Fractions are your friends. Okay. But fractions can also be manipulated so that your rational function is in standard form. Okay, so what we're gonna do is gonna go through how can we manipulate it so that it's in standard form. So that's step one, is that we need to be in standard form, right? So what we have to do, how many of you remember least common multiple?
When did you ever say that in your life?
Your fifth and sixth grade teacher.
Oh, no. One.
No one knows what a least common multiple is?
I don't remember. I haven't heard of it.
All right, your least common multiple is the smallest number that both numbers evenly divide into. So what would be the least common multiple between 3 and 2? No, that's GCF. I'm saying LCM. Least common multiple.
Is it one?
Your least common multiple. What is the smallest number that thank you, 6. Your LCM is 6. What is the smallest number that each one of these numbers would evenly divide into?
Oh.
Your greatest common factor is what is the greatest number they have in common as a factor.
That would be one.
Their GCF would be 1, exactly. Yes, their GCF would be 1. Okay. When there's a fraction, you want to find the LCM. And what you're going to do with the LCM, so you find the LCM of the denominator, and what you're going to do is you're going to multiply each terms by it. No, you're multiplying it by 6. Okay. So what ends up happening is I'm going to have 6 times 2 over 3x. Oops, my x is not in the denominator anymore. There it goes. 2 over 3x plus 6 times 3 over 2. When you're multiplying a fraction times a whole number, you only are multiplying the whole number to the numerator. Does that ring any bells in your mathematical history? Yes. A common denominator. Yeah, no. We're trying to get rid of the denominator. Okay?
Remember we multiplied the top.
That's going around the world. That's your mixed numbers. When you're multiplying a whole number times a fraction, you're only multiplying the whole number to the numerator. Okay? When you're multiplying, you're only multiplying the whole number times the numerator. Okay? So 6 times 2 is 12. 6 times 3 is 18. There you go. Good job. So when you simplify, it'll now be in standard form. What is 12 divided by 3? 4. What is 18 divided by 2? 9. So now I'm in standard form.
So now be y equals 4 over x plus 9.
Exactly. So now you're doing y equals 4 over x plus 9.
Is this the homework?
Maybe.
Oh, rule 92. That's an A.
Exactly. So we now know our A. Your A is what? 4. Your H is 0. Good job. And your K is 9. So therefore, my asymptote, x equals 0 and y equals 9 are my asymptotes. X equals 0 and 1, 2, 3, 4, 5, 6, 7, 8, 9. So step 3 is your table. And your table is based off of your y equals your a over your x. So 4 over x. Is it okay if I just do 2 and 1? Is that going to bother anyone? So I'm just going to do -2, 1, +1, and +2. You could have done 4, obviously, but I didn't want to. Okay, 4 divided by -2 is Oh, that got weird. Is -2. 4 divided by -1 is -4. 4 divided by 1 is going to be +4 and 2. Again, these are my what? Directions. That's all ordered pairs really are, right? They're your direction from your starting point. But since we're not starting at the origin, we're starting here. So I'm going to go left 2 and down 2. 1, 2, 1, 2. I'm going to go left 1 and 1, 2, 3, 4. And here is my left branch of my function. I can't do the right one. I mean, you can estimate if you want. And then right 2 and up 2. I can do that one. So the graph is doing something like that. Because this would be if I was at the origin. So instead of me having to plug in each one of these points into this and then adding 9, I can just count from here instead of having to do the adding of the 9. Okay. So final. You should be able to tell me the domain. What's the domain? X. Perfect. X cannot equal 0. So -infinity to 0. Join with 0 to infinity. What's my range? Y cannot be 9. So from -infinity to 9, union 9 to infinity. Okay. All right. Questions, comments, concerns about 3.5b? No? Okay. Following those 4 steps will be your best friend.